Hey guys, I figured while I got this Admiral chassis on my workbench from my little experiment with this picture tube, I might as well tune up this chassis. This is the chassis for my Admiral 24A12 I did a restoration series on, I think about a year ago or so. If you search through my videos, you'll find a whole bunch of videos on it. Well, when I restored it, I didn't have most of this test equipment. I did not have a good test pattern generator. I didn't have these nicer new sweep generators. So I figured it would be a good way to break them in to align the set again. Also, the set has a problem. You may have noticed in the video on my 10XP4 that I never had any sound coming out of this set. Well, that's because, well, there isn't any. Or I should say, there's no audio when I have a good picture, but if I take the fine tuning and crank it over, then I get sound, but no picture. That's the problem with these split carrier sets. What I mean by split is, after the tuner mixer oscillator here, they separate the IF stages. This chain here is the video, and this is the audio. So they're two completely independent circuits. So I suspect that they're out of alignment, and I need to bring them back so that you can get both a good picture and sound at the same time. Also, I want to replace these mica caps. I think there might be some in here too. I did that on my Admiral 24C16. I recorded a video on that a while back when I used my Hickok 615 to align it. The mica caps in here are actually made with just these exposed sheets of mica with some metal foil in between. They're not encapsulated or anything, they're completely exposed to the environment, so these can go bad, if moisture and corrosion gets in there. So I'm going to get these out. Basically, you take a small tool like these pliers here and kind of nip this away very, very carefully. And then I'll put in some new mica caps. Here are the caps I'll be using. I think it's these guys, 30 picofarad caps, so one goes on either side of this coil. I also want to test all these tubes because since I got this set, I got a better tube tester. I'll be using my Hickok Cardmatic tube tester. And yeah, I'll fire up this leader test pattern generator and get the horizontal and vertical linearity all squared away and get the picture centered. I'm also going to be taking this 10XP4 out and putting the 10BP4 back in this set, because it still has some life left, plus I want to get this focus coil mounted back on there like it's supposed to be. And then for aligning it, I figure I'll do the 615, although I am going to retire this because it just takes up too much space on my workbench. And then I'll try using this for the very first time, and this for the first time. And 369, I have used it a bit, but I don't think I recorded a video on it. I did part 1 on the 369 a while back where I just poked around inside and did a little experimenting with it. Well, since then I finished recapping it, and it seems to work okay, but I have not gone through and calibrated the markers well. This will give me a chance to see how well it really works. And maybe I'll even try using the WR514A. However, I still have not tracked down a manual for it, so I'm going to have to kind of guess as to how exactly you're supposed to use it. But they do label these connectors here, so I think I can muddle my way through it. The IF stages in this set are what they call stagger tuned. And it's something I've been meaning to talk about for a while, but I didn't have any good illustrations to kind of explain how it works until I came across this book. This is put out by Howard Sams. It's a like a home study course on working on vintage TVs. And They explain it quite well, I think, here. So the overall response of the IF stage is something like this. So if you had to design a circuit like this, your first thought might be, well, I'll just make a bandpass filter. But the reality is to get a bandpass with exactly this curve and this wide of a response, which is I think about 4 megahertz, it would be very difficult, if not impossible, to do. So a very clever workaround for that is this. You don't make one filter that gets that nice big wide bandpass. You make like 5 or 6 that have that usual just peak resonant curve that you get when you put an inductor and a capacitor in parallel. And if you do it with certain amplitudes and certain frequencies, so you add them up, so you get this IF stage, this stage, this stage, this stage. If you measure from the input to the output through all these stages, you actually get that wide, flat plateau kind of bandpass response. So when you align this set, you actually don't need a sweep generator. What you do is you get a fixed RF generator and you do each one of those sections. This one to 21.25 megahertz, and then 25.3, 23.5, 22.0, 22.3, and all those added together give you that nice wide response. So the only thing you need a sweep generator for is to check your work after you're done to make sure that this overall response is like this. And you actually tune each one of these coils to these frequencies. I label it right on here. So when I go through all these 10 steps of aligning here, the only time I need to sweep is right down at the bottom, step 10. Very clever, I think. Well, I'm glad I took the time to test these tubes, because the second one I've tested so far is bad. Got all kinds of shorts. It's a 6AU6 tube. There's a whole bunch of these used in the video and audio IF stages, so this could be accounting for some of my audio woes. Luckily I've got a lot of these on hand. The 6AU6 is one of the most common tubes in late 40s TVs. I just found another 6AU6 that's got a lot of secondary emission. This needle should be on 0 and none of the buttons are pushed, and it's up over 15, so I'll be replacing that guy too. I'm down to testing the last tube in the IF section. I tested all the other 6AU6s and they were all pretty good. This is a 6AL5. It's used as a ratio detector for the FM audio circuit. And it measures pretty darn weak, so I'll be replacing this too. I'm curious to see how the set will perform with new tubes in there. I've been disappointed in the past, though, when I've worked on other sets and I find some weak tubes and replace them, and it really doesn't make much difference. It's surprising how resilient sets are to work with weak tubes in a lot of cases, but we'll see. Hopefully it'll make an improvement. Finding a good replacement 6AL5 is turning out to be far more of a challenge than I ever imagined. I'm going through my stash, and so far I got 6 that are bad. Some of these filaments are completely dead, or they test horrible, like this one. Just barely registers at all. Well, I have 2 more left. Otherwise I might have to go online and order some. That's just sad. I don't know why these are all so bad. Filament's lighting up on this one, so keep my fingers crossed. Ah, excellent. This is a 2-section tube, so for the other section you have to hold down this button to test. Phew. Alright. I have a good one finally. The picture tube in this set rests on a couple sliding steel plates with a rubber pad on top. I think that was to accommodate either a 10 or a 12-inch picture tube. If you spread these further apart, you can put a larger picture tube on, like my 24C16 in the mahogany cabinet I did some videos on. Same chassis, 12-inch tube. There's also then like a bumper plate in front so the picture tube can't slide off. And there should be some rubber on the back of that, but this is all hardened, so I'm going to put a new strip of some modern like leather stripping kind of material. And finally there's a cloth strap that wraps around the picture tube and gets attached under some metal plates here to provide tension to hold it down. But before I can put that back on, I want to get this rust off. Bled through it onto the cloth too. It's probably got damp at some point in this cloth, or like burlap, whatever this is. Kept the moisture trapped in there and caused the metal to rust. So I got out some navel jelly and a little brush and I'm dabbing some on. Hopefully that will take care of it. As I was getting ready to put this focusing magnet back on the CRT, I noticed that the cardboard cover on the yoke was loose, so I thought I'd slide it off and give you guys a closer look at what's going on inside there. There are several large coils of wire in here, and these provide the magnetic deflection to move the electron beam both up and down and left and right. But there's also some parts in here, and it's not out of the question that these could go bad. There's almost always a couple of 560 ohm resistors across the vertical coils and a capacitor or two on the horizontal coils. It's a mica cap, probably okay, and the set seems to be working more or less, so I'll leave that alone. But I'll check these resistors. What the heck, they're right here. Easy enough. I might have to unsolder one leg of them though. I don't have the schematic in front of me, but I think these go in parallel with the coils. And if I try to measure these, it's just going to measure the super low resistance in the coil instead of the actual resistance on the resistors themselves. I dug through those rider's service manuals I picked up recently, and in this ratty copy of Volume 4 I found this set. Some of the pages are a bit damaged, but schematic should be in here. So yeah, here it is. Yeah. I guess somebody taped it back together with Scotch tape many years ago, and it's all turned yellow and nasty, but I can certainly still read it. So let's see. Where is the yoke? Oh, here we go. Vertical output. Yeah, those 560 ohm resistors are in parallel with the coil, so I'll have to remove one end of each resistor to measure them independently. I unsoldered one end of each of these 560 ohm resistors, and they're both off, and this one especially is 738, so I'm going to be replacing those. Now, as you saw earlier, this set was working and it looked okay, but I am going to get a test pattern generator on this, and one of the patterns is a grid, and I want to get those squares as square as they can be all around the picture, top to bottom, left to right, and in the middle. And these could have a very minor subtle effect on the vertical linearity, so I will be replacing these with some new metal film 560 ohm resistors. I've got the yoke and the focus coil all buttoned up and reassembled. So back to these IF cans and the capacitors. Here's the first one, which is on the schematic here. And it says it should be 30 picofarad and 30 picofarad. So I'm going to very carefully nip out this mica with these cutters here, and then pop in a couple of these 30 picofarad mica caps. It was a little tricky, but I did finally manage to nip away all the old mica capacitor and mount it in the new capacitors here and here. And while I had the cover off, I took the opportunity to polish it up. So I think it looks a lot nicer now. It goes back on like so. There's also a mica cap on this coil, but I've seen some discrepancies in the schematics about what the exact value should be. On some schematics it's unmarked. On this one they show it as 35, which is an oddball value. The closest I have is 39. So I think I'll just leave it alone for now and go through the alignment and see how it goes. If there is any issue with this, I'll take a look at that capacitor though. This is the coil for the FM discriminator, and that's the final stage, and that's the one where you get that nice kind of like sine wave looking curve like I showed in my video on aligning FM radios. So if I have any trouble getting that nice balanced FM discriminator output, then I'll take another look at that. But while I got this off, I might as well polish this up too. Alrighty, I've got the new mica caps installed to put the IF shields back on. I installed all of those tubes I had checked. Got the tube shields on, got the CRT mounted, strap, focus coil, everything. So now I want to turn it on and see how it plays before I attempt to do any alignment work. Make sure everything's pretty much the way it was before, and see if putting in all these nice tubes had much effect. Oh, it sounded. That's good. Probably have to adjust this ion trap magnet on here, so make sure I put it back in the right spot. There we go. That looks pretty good. So let's see. Yeah, so it's still like before. I get the best sound when the picture breaks up, and when the picture looks sharpest, no sound. So now it's time to go through all the alignment steps.